Uh, Hello all. Today we have presentation on 5G transformation with open source 2020 ONF Spotlight series. My name is Ajay Thakur and I am member of technical staff at ONF. I am SD Core team lead for Ether project. Today we have distinguished guest from National Chiao Tung University, NCTU, is a research university located in Taiwan and is one of the leading university of Taiwan. Our first guest today is Jyh Cheng Yan-Jie Lin, Dean of College of Computer Science and CTU. He has received numerous awards and he is fellow of IEEE and a distinguished member of the ACM. Our second guest is Yan-Jie Lin. He is a master student in the NCTU. It's my pleasure to have you here, Jyh Cheng Yan-Jie Lin and Yan-Jie Lin. Over to you.
So my name is Jyh Cheng Yan, and I know it's difficult to pronounce my name, so people usually call my initials JC. So you can just call me JC. And the title of my presentation is Free the Cellular Core Network by free5GC, and the demo of free5GC is IoTtalk. Free5GC is an open source developed at the National Chiao Tung University. So here is the outline of my talk. First, I'm going to give a very short background, and I'm going to discuss our open source project. The first one is called Reconfigurable Core Network, RECO, and then the second one is called Service Level Virtualization, SLV. And most importantly, I'm going to discuss free5GC. And after my presentation, Yan-Jie is going to show the demo. So what's wrong with current 5G core network? Of today's 5G core network. So as you can see, there are many different components in today's 4G core network, and all of them have different features and different functions. Most importantly, all of them are designed. Those 4G components are designed for human beings to use the core network. And as we can know, in the future 5G applications, they are going to many machines, such as self-driving cars and many IoT devices. Because the 4G core network is designed mainly for human beings, rather for the machines. So basically, the 4G core network cannot work efficiently for those machines. If you go to the central office of a cellular network operator, you are going to see many such machines. They are all proprietary hardware. They have specialized hardware. They are specialized hardware, and they have specialized features, and they are all very expensive, so the cost is very high, and they are not flexible because once they have been implemented, they cannot be changed easily. And most importantly, they limit the innovation for us at the university if we want to implement new idea, because those hardware are specialized hardware. It's almost impossible for us to implement our new ideas. So how to solve the problem? So in 5G, we know the most important is the virtualization and the softwareization. There are many research topics for the softwareization and the virtualization. I can list many of them. And the most importantly, we want to have an open 5G core network. So here, let me show you an example. This research is done in around 2000. Actually, we published a paper in 2005, and the research was done in around 2003 and 2004. At the last time, it was still 2.5G. So in 2.5G, we had the GPIs, and at the university, we proposed a new idea to improve the mobility measurement in GPIs. We conducted mathematical analysis and the computer simulation. After that, we wanted to implement our idea in the real system, in the real core network. And we try to approach many operators in Taiwan. Almost none of them allow us to use their equipment because those equipment are very expensive and they are not available for academia to use them. Fortunately, we found the operator which is called Taiwan Cellular Core Taiwan Cellular Corporation, they allow us to use their video core network. You can see the models of those machines in Taiwan Cellular Corporation. Basically, they are from Nokia and Siemens. And I send the students to Taiwan Cellular Corporation. It turns out to be useless. Why is it useless? Because the network operator, they only have the machines. They have the hardware. They don't have the source code. Without the source code, it's impossible for us to implement our idea in GGSN and SGSN. So since then, we have always wanted to develop open source core network for everyone to use. For doing research in core network, the core network basically are very expensive and it's not easy to access the source code. And I just mentioned, without the source code, it's almost impossible for us to implement our idea. So people usually could only conduct mathematical analysis and simulation to verify their ideas. With open source networks, researchers can implement and test their proposed algorithm in the real test bed. That's the motivation for us to develop the open source core network for everybody, not only academia, industrial companies can also use our open source core network. So we started to implement our open source core network. The first one we call Recall. So it's around 2015, 2016, and we published a paper in 2017. The idea of Recall is that at that time we wanted to implement the idea of network slicing in the 4G core network. At that time, because at that time it was around 2016 and 17. The standard of the 5G was not standardized yet. So only thing we could do was to implement the idea of network slicing on top of a 4G core network. So basically, Recall is a 4G core network with network slicing. And then the idea of Recall is quite simple. We have some common libraries for common slices, and we implement those spatial libraries, spatial modules, and we have a dynamic linking framework. With this dynamic linking framework, on top of the general purpose hardware, or we call the commodity hardware, we can virtualize them, and we can create many network slices. And in each network slice, we have many virtualized network functions. And in one of the network functions, we implement the idea of Recall. So we can pick out the modules we want for this module specifically, and then combine the common modules, which is common for all different virtualized network functions together. Then we can create a network function. And by using the same way, we can create many virtualized network functions. Combine those network functions, then we can create one of the network slices. By using the same way, then we can create many network slices, and both of them are virtualized on commodity hardware. So that's the basic idea of Recall. And then next, we developed our second version of the open source core network. And we had a paper published in 2018. The second version of our open source core network is called SLV, Service Level Virtualization. So at that time, the standard body 3GPP release 15 was not standardized yet, but people always knew that. It's called service-based architecture. So we try to implement the idea on top of the 4G core network. We implemented the control center and the service center. Inside the service center, there are many microservices. So basically, we have a service center here. Let's say we have 3 users. The 3 users, they have many common parts which are in gray area, and the 3 users only have a very small different part which is in the white box. So the first user can gather the service the first user wants from the service center. Then this user can gather the network slice the user wants. By using the same way, the second user and the third user can all get their services from the service center. By using this way, as you can see, although only one small piece is different, we can create 3 slices very efficiently. We can save the resources. So that's our second version of our open source, which is called service level virtualization. And as time goes by, the standard, the 3GPP release 5, release 15 has been standardized. So we try to implement our second version of open source. It's based on the 3GPP release 15. Specifically, it's based on the standalone architecture. In the 3GPP release 15, the standalone architecture is called, the core network is called free5GC, and our open source is called free5GC. So this figure shows the architecture defined in 3GPP release 15. There are so many network functions. The purpose of free5GC is to implement all those network functions defined in the standard. And we try to implement some of them, then release the first version of free5GC. So our first version was released in January 2019. We implement the most 3 important network functions in 3GPP release 15, ANF, SNF, and the UPF. And in this version of our free5GC, we still kept the S1 interface, which is the interface to 4G radio access network. So in our stage 1 implementation of free5GC, we could connect to the 4G base stations. Then in October 2019, as you can see, we have implemented so many different network functions. So in our stage 2 implementation of free5GC, is quite complete. In April 2020, so we released our stage 3 of free5GC. So there's one application, IPTV, is supported in this stage. And we also implement the OAM, operation, administration, and the management, orchestrator, and the network slicing. So for the stage 3 of free5GC, it's quite complete already. Here I want to give you a very quick overview of the computer industry. So as we can see, around 30, 40 years ago, there were only 2-3 big computer companies. They sold the hardware and the software all together. Later on, we all know like software and the hardware are separated. So the computer industry has been changed dramatically. Many companies can produce hardware, then use the software. So today, in today's cellular industry, it's quite similar to the computer industry 30, 40 years ago. Right now, the cellular network industry is dominated only by a few giant, a few very big companies. And our vision is like, in the future, we want everybody can, many companies, hardware companies can produce their hardware, and the software and hardware is also separated. They can download free5GC. So by this way, we think the whole cellular industry will be changed dramatically, and the cost could be down, and eventually all users can be benefit from the separation of software and the hardware. And for the demo of stage 1, we put a core network in a server, and we can use the commercial base stations. This is stage 1. That's for we have 5G core network, and we use the 4G base station and the 4G cellular phones. So basically, you can use any 4G cellular phones And when you use the free5GC, basically you are an operator. You own the network, so you need to produce the SIM card by yourself. And later I'm going to show you the link of free5GC. In our link, you go to the website of free5GC, and you can see the YouTube video. We have many YouTube videos. One of the videos is to show you how to program your SIM card. So you can buy the blank SIM card, and you can program the SIM card by yourself, and plug in the SIM card inside the commercial handsets. Then you can connect to the commercial base stations. And in our lab, we have already tested some commercial base stations successfully. Those commercial base stations basically are from the local companies in Taiwan, including WNC, D-Link, Gemtech, Foxconn. All of them are the local companies in Taiwan, and they provide us the commercial base stations. But you can use any base stations, not limited to those commercial base stations, as long as they follow the standard interface. Because our free5GC is based on the standard, so any commercial base stations follow the standards should be able to connect to the free5GC. And this is our core network. We use the Dell PowerEdge, but you don't need to. It's not necessary for you to use the Dell PowerEdge. Any laptop, desktop should work if you don't care about the performance. As you know, if you use a desktop, you may only connect to, let's say, 2 or 3 users. If your core network is more powerful, then you can connect more users to your core network. For minimum requirements, please refer to our website. Okay, so here is the link of our free5GC. As I just mentioned, for our stage 1, we capture the interface for 4G base stations. And then next, we are going to show you the demo for our stage 3. And in this stage 3, we don't keep the interface for 4G, so we need to use a 5G base station. But right now in Taiwan, we still don't have the 5G standalone base station available yet, so we use the simulator. And then next, Yan-Jie is going to show the demo. So Yan-Jie, please take over from here.
Okay, hello everyone. I am Yan-Jie Lin, and today I will present to you about free5GC with IoTtalk application platform. And first, let me explain the demo architecture. You can see the picture with gray shade is free5GC. And in the demo, I will run free5GC in the one virtual machine, so I call it VM1. On the right side is the IoTtalk platform. It is on the internet, and it can connect to many IoT devices. On the left side, I put a 5G run and UE simulator in another VM, so I call it VM2. Initially, there is no any internet access at the run and UE simulator side, which means that the simulator cannot access the internet. There are 2 mandatory steps we need to perform in order to access the internet. The first step is registration procedure, and the second step is PDU session establishment procedure. After these 2 procedures has been done, then the UE simulator can access the internet, so it can connect to IoTtalk platform through free5GC. And these are the demonstration steps I will present to you today. First, I will show you the final result. That is, UE simulator can access the IoTtalk. Then we need to reproduce the whole procedure by resetting the UE simulator. And we need to release the PDU session and deregister the UE simulator from free5GC. After that, the UE is out of internet access, and we can check the internet connection by pinging the IoTtalk website. After that, we need to show you how to resume the internet access. Again, we need to perform registration procedure and establish the PDU session. And after that, we can check the UE internet connection by pinging the IoTtalk. Finally, we can reload the web browser to access the IoTtalk platform. And this is the final result you will see later on. And it is a smart agriculture application. It shows a application dashboard and the live video streaming. And that's that. With internet connection, the ping action will get responses. And with no internet connection, the ping action will get no response. Okay, let me go back to a demo. And so you can see on the screen is the IoTtalk platform. And as I mentioned before, IoTtalk is on the internet, and the UE simulator access IoTtalk through free5GC. So you can see that our run and UE simulator is running on this VM. The top is the run simulator, and the bottom left is UE simulator. And free5GC is running on another VM. So you can see this VM is running free5GC. And in the demo, I make it always running. Okay, now we need to reproduce the whole procedure. And to do this, I need to release the PDU session and deregister the UE from free5GC. So you can see the bottom left. I need to key the commands to delete the session and deregister the UE. So now you can see I've disconnected the UE and free5GC. So now if I want to access the IoTtalk, the ping will get no response. So you can see the button right. Okay, now to make it reconnect to free5GC, we need to register the UE simulator. Again, you can see button left. I type the commands and add a PDU session. So now you can see the two procedure has been done. And now if I want to pin the IoTtalk platform, you can see that ping get responses again. That means you get the internet access again. So now we can go back to the web browser and reload the page. And you can see that everything is working now. And our demo has been done. Thank you for listening. Any questions and comments?
Yeah. First of all, I mean, this is great to see the so much mature 5G and as well as 4G core network project being available as open source. And you had done the excellent demo where it really seems easy to use the whole project. Doesn't find, I mean, I don't see any difficulty in using this. But let me just ask a couple of questions, right? In the demo, you had shown the UE simulator and 5G RAN simulator. So is this something developed by NCTU or is it something commercially available simulator?
It's by us, developed by NCTU. So Yan-Jie, do you want to comment on that?
The simulator is developed for demo usage. So the demo is developed by us.
Okay.
Yes.
And is that also open source or that's the closed-ended?
It's closed because we focus on core network, so we don't plan to open source the simulator.
So the RAN simulator is only for internal use. Yeah. Mm-hmm. And right now, because some local companies in Taiwan, they are working on the 5G SA, I mean standalone base stations, and they are going to be available very soon. So once they are available, we are going to test the free5GC with real commercial 5G standalone base station. I want to emphasize on the SA standalone because right now some people will say they are 5G base stations, but most of them are based on NSA non-standalone base station. And right now we also, I mean, for our test, for our internal use, we also use Spirent. You know, the Spirent is a really big international company. They have a 5G simulator which is called Landslide. So we have tested free5GC with Spirent Landslide already.
Okay, so is that for functional testing or you have done some kind of a performance test or scale test to?
Mostly are for functional tests only by using a spider, which is to make sure our implementation comply with the standard.
Yeah, it's really interesting to see how the project started. The main motto seems to be to motivate the researchers to carry out their own experiment on the free 5GC or maybe EPC core network. So I just wanted to understand few things. Like now we have this whole EPC, which is going to simulate the network, which is as good as the real telecom network. But how do you manage to simulate the background traffic or users so that your experiment really get the correct result?
You mean how do we make sure our implementation is correct? Is that your question?
My question is, like, in the real network, you will have maybe a few 100K users or maybe millions of users in the real network, and that EPC network is really carrying out that much signaling load and as well as user plane load. How do we make sure our experiments are getting the similar load in the while we deploy the free 5GC?
Okay, so basically, you want to know, let's say there are 1 million of users connected to the 5GC. How can we make sure that work? So to answer this question, yeah, okay. To answer this question, so basically in our open source implementation, we focus more on the functionality rather than the performance. So basically we make sure our implementation is based on the 3GPP release 15 standard. And if you want to have a good performance, and first of all, you need to have a good hardware. And secondly, the software, you need to have some optimization and the performance optimization. So in that part, we don't focus much on that. So when people use free 5GC, they can get the open source, which is based on the standard. And if you want to have a good performance, so basically, it's an open source. It's we basically focus on functionality. For the performance, users will need to improve that by themselves.
Now, given that 3GPP is quite a big, it's a major hurdle for newcomers to come in, and you have successfully achieved getting the functional 4G and 5G core. I just wanted to know, like, what kind of release this project is compliant with, and how do you catch up with the multiple 3GPP releases coming in?
So the question is that how do we make sure our implementation comply with the standard? Is that right? Yeah. So basically, we have a dedicated person which attend the 3GPP meetings regularly. So the person goes to a 3GPP meeting and bring out the information back to us. And in addition to that, we try to test our free 5GC with the spiral landslide, which is a 5G simulator. And in our stage 1, we also test out free 5GC with commercial base stations and commercial handsets. So that's the way we can make sure our implementation is based on the standard. If our implementation is not, if our implementation does not follow the standard, then the test, the interoperability test will fail. So that's the way we can make sure our implementation is based on the standard.
Okay. So how does if someone is interested in contributing to this project, how does this work?
If anyone wants to contribute to this project, basically we put everything in GitHub. So in GitHub, people can contribute to free 5GC by following the procedures in GitHub. Basically, they look at the source code, and if they find some issues, they can send out a request, and they can based on their request, based on their request and based on their implementation, if the implementation is good and can be merged into our source code, and we will merge the contributors information into our source code, into our project, and the contributor's name will show up in the GitHub. So basically, we follow many different open source projects. So we welcome everybody contribute to free5GC.
Okay, yeah. Thanks for that. But my next question is about the support you provide for anyone who is using the free5GC code. What kind of support model we have?
So basically, our source code is based on Apache 2.0,
Okay.
which means anyone can use our source code for commercial purposes, and anyone can modify the source code, and they don't need to contribute back to our open source project, although we welcome the contribution back to our project. So for the support, in our website, there's a forum. People can register and ask a question in the forum. We will try to reply. We will try to reply to the question, to those technical questions. And if people want us to reply very quick, let's say within one business day, then we welcome everybody to join our membership program. So if you go to our free5GC website, you can find a forum. The free5GC forum is free. Everybody can ask the questions there, and everybody can answer the questions. Although most of the people answer the question are from our team. And if you want to have a good technical support and you want to get a response very quickly, so if you go to our website, you can see we have a membership program. And you can pay some money, and we can guarantee to answer you very quickly.
So is there any plan to use the Slack kind of communication to give the better support, or maybe quick support so that multiple community members can also talk?
Could you repeat your question again?
Yeah. So do we have a mechanism like a Slack where community members can talk among themselves as well and they can discuss and help each other?
So far we don't have that yet. So, but we will try to bring up that in the future.
Okay.
So, for example, in our membership program, we have some meetings for all those for all our members. They can come together, discuss the future plans, and they can communicate to each other during our meeting. That's our future plan. We don't have that yet.
So, one of my next question is like on the demo. So on the UPF side, I see that we have N3 and N4 interface supported. So the UPF supports current UPF supports both S6 as well as N9 interface, or only N9, or maybe only N6.
You mean N9 interface? Because I'm not implement the UPF side, but I think.
Okay.
I think basically we implement the N3, N4. I mean those interfaces we show in this figure.
Okay. Yes. So I had quickly browsed through the code, and I could see that UPF is the one which is bit tied with some specific kernel version where GTPU is a part of the kernel. So like, is there any specific reason with going the kernel module approach?
Because in a user plan, UPF need to send GTP packet, and to improve the performance and some GTP header defined by free5GC. So we need to implement our own kernel module. So we need to specify the kernel version. That's the reason.
Okay. So and whatever development we do, I understand that you are using the Spirent test tool. So is it the Spirent test tool used to make sure that the developed code is standard compliant?
Yes. We mainly use the Spirent landslide to make sure our implementation is based on the standard.
And is the whole software like containerized, like any like it just we can just download container and start it, or it is like it has to be run as a standalone processes on the machine?
So basically, you can put the source code everything in a container. We test that already, and you can. I mean, it's based on what you want. If you want to run them on a physical machine, that's fine. And then if you want to put in a container, you can do that also.
Okay.
Yan-Jie, do you want to comment on this question?
In our GitHub, we have open source Thakur Compose project. That is, we build all the NF one by one in one NF in one container. So everyone can go to GitHub and download the Thakur Compose, and then he can run NFs in container.
So, given the maturity, do you expect, or do you are you aware about any operator using this project in the real network?
So far, I think no operators are using this because right now, I mean, for free5GC, actually we don't expect operators to use free5G at this moment yet, although that's our goal. And we see that probably in 5G private network, that may be more feasible. Because right now, as I mentioned earlier, we focus on functionality, not on the performance. For an operator, they may have a million, I mean, million of users. And at this moment, free5G is not ready for that yet. But for private network, for local network, maybe they only need to have 1,000 users. So free5GC could be used for that. And in Taiwan, we are trying to have a proof of the system. We are working with some local companies, try to put a free5GC in a local, I mean, in private networks.
So given the current stage of the software, what is your next plan? How do you want to take it forward?
First of all, we want to implement more network functions based on the 3GPP release 15. And the next one, of course, will be 3GPP release 16 and 17, so on and so forth. So basically, our first goal is try to implement the standards as quickly as we can. So let's say release 15. When after release 15 was standardized, after around 3 or 4 months, then we finish our implementation based on the standard. So one of the major purposes of free5GC is to convert the standard from English to computer, I mean, to the source code as quickly as we can. So that's one of our major goals. And the secondly, of course, is on the performance. We will try to let free5GC have a good scalability. Try to let free5G can be able to accommodate a lot of users and have a good performance. That's our second goal. And our third goal is that because free5GC is based on software. And as people know, in Taiwan, there are many hardware vendors, hardware manufacturers. So we want to work with them. And they may have a white box. And they may have some, I mean, they have some special design for their hardware, for example, for UPA. So let's say one company, they have special hardware for UPA. And we will try to customize our source code for those hardware vendors. So that's our third goal for free5GC.
Interesting. So I have a couple of more questions. So one of the question I have is around the SIM card. Can you please elaborate like more thing about the SIM card and how let's say some organization takes this software and they want to have their own private network, how they can do this?
So for SIM card, so basically, you can buy a blank SIM card. And then you can buy a card reader, card writer. You can program the SIM card by yourself, like an operator. I mean, like today's operator. You go to operator will issue a SIM card, and you use free5GC. Your role is like an operator, so you can program your SIM card. And how to program SIM card? We have video in our YouTube channel. So Yan-Jie, do you want to comment on this?
Let's just Professor says so. And there are many open source programming SIM card tools on the website. So anyone can download the open source programming and to program their SIM card. Yeah.
Actually, it's not that difficult. Especially we put a YouTube channel there. There are some other tutorial videos available on the internet.
So yeah, so as a part of this core node development, did you see any issues around the handling the different handsets, different commercial handset, or you see like those things just work seamlessly?
Based on our experience, so because free5GC connect to the base station, so handset actually is not a big issue because handset communicate to the base station, then base station to the core network. So our main issue is on the interfaces to the base stations, and for the interface to the base stations, theoretical, everybody follow a standard, it should work, like in theory. But in practice, there may be some issues. For example, in the standards, there are some options. Some base stations some companies may not implement some options. So sometimes it won't work. The good thing is that because in Taiwan there are many local companies working on the base stations. They are nearby. NCTU is in Hsinchu, which is Silicon Valley of Taiwan, and those companies all are in Hsinchu. So we can see each other. We can work on the problem face to face inside the lab. So that's a good thing about our location. So I think that's all. Yan-Jie, do you want to comment on the interfaces to the base station and to the handset?
Nope.
No? Okay.
Yeah. Yeah, I mean, it's great to see such a good work done by university, and it's not just a small effort. I can see that you have done it for a long time, and it's a dedicated effort. It's not like something is done and left it in between. I see like you have planned to take it forward and doing many more things for the community. You are aware that yeah.
Yeah. So sorry to interrupt. So one thing I want to mention is that initially, I only have graduate students, master and PhD students working on the project. I mean, for Recall and the SLV, and because we showed a demo for Recall and the SLV. I mean, our earlier versions of free5GC, and we got the support from the government agency. And in my team, I started to hire professional engineers. So right now, I have 7 professional engineers working on this project.
Wow.
To master and PhD students.
Yeah, that's great. So that means we can expect a much more faster development and much better support, given that you have much bigger team size now.
That's right, especially the full-time professional engineers.
Yeah. I'm sure like you are aware that ONF as an open source company, we do have a couple of projects in the mobile area as well. One of the project is around the core network. I wish you can also see some of our papers and website to see what is it that we are doing, and our projects are also open source, and it's good to see that many more open source projects coming around the core network, which was typically nobody wanted to do this because of heavy standard
That's right.
in this area. And when when we search some of the free or open source project, I do see that free5GC does come on the very first page of the Google. So yeah, I mean, that definitely tells that there is a lot of traction on the free5GC project. I really enjoyed this talk, and thank you very much from my side. You can add your final note. Yeah.
Thank you. So
Thank you.
so I think that's it. I don't have any final note.
Yeah. Yeah. Thank you, sir.